Hi, this is Kirk Davis. I'm here with Jake Cusdy, the inventor of Echo. Jake, we've been getting some questions about Echo and its application. And one of the questions we've been getting is, how does Echo compare to current treatments for the coronavirus?
Excellent questions that we've been getting back. The current treatments, we've been hearing about them on the news, on the President's Live updates and all that. We've heard a lot about ventilators for quite some time now. And, as we've recently heard, ventilators might actually be causing additional damage. So they're looking for alternatives. One of those alternatives is ECMO. And ECMO is, just hit the news with a couple of popular cases, one in Arizona, one here in Seattle, that the COVID-19 patient was fully expecting that's it. They're at the end of their treatment and they're not going to make it. The doctor up here at Evergreen was, even said goodbye to his family, told her where his life insurance was. Got put on. You can read about that in the Seattle Times. He got put on ECMO, and he's fully recovered and back home with his family right now. So that's kind of our current treatments today.
Can you explain real quick? So the ventilator, is usually a tube or a breathing, and it's forcing air down into the lungs. How is ECMO different from respirator?
Yeah, so ECMO is used. You could compare it to like a heart-lung machine. It pulls the blood out of an artery, puts it back in a large vein, traditionally in a VA scenario. Alternatively, is what we call a VV scenario, which is veno-venous, where it pulls it out of one large vein, puts it back into another vein. That's primarily used for respiratory assistance versus the VA.
The respirator is because they're in respiratory distress from the virus, and they can't breathe.
So right, their lungs still have to function properly for a ventilator to even work.
But with that, they're actually putting the oxygen in the bloodstream, which is proving to be very effective.
Exactly. Unfortunately, the criteria for being on ECMO right now, as we learned from Dr. Carl Kaufman's testimony on this, is that it's widely unavailable. There's about 264 centers in the U.S. for ECMO. That's nowhere near enough to handle a pandemic. It's not even enough to handle normal respiratory distress on a normal year, so to speak. These machines are widely used for surgeries and transplants and other more critical situations. Right.
Now,
so
something you said to me, Jake, is that these are expensive machines and they require a lot of training. So it's not like we could just ramp up overnight and have a bunch of machines and trained personnel.
Exactly. Not only a lot of extra training, but a lot of continued training. Much like most specialty professions. For the prices that we've seen on these ECMOs are in the few $100,000 range. One doctor used the terminology: you can buy an ECMO or you could buy a Ferrari. It's your choice. And unfortunately, there's a lot more Ferraris in the U.S. So with ECMO, it's an absolute. You're doing the job of the lung mechanically. The main component with an ECMO that attracts us and attracted our design is right there over your shoulder. It's the blue component, other side there. Yep. And that's the blood oxygenator. And there's a dozen different brands of them in various shapes and orientations, but they're all very proven technology, grounded by decades of use.
FDA.
So FDA approved, tested, vetted, everyday use. And what we're doing is we're actually taking that oxygenator that has all that history and has all that efficiency built into it. And we know everything about that oxygenator. And we're taking that, we're simply using the pump and the console and various sensors out of a hemodialysis machine, replacing the expensive part of the ECMO machine. And because of that, we believe that with the, hundreds of thousands and millions of hemodialysis machines in the world, this becomes a force multiplier to ECMO.
So Echo is actually applying this technology to a kidney dialysis machine, which is widely available.
not only applying the technology, but applying the actual physical unit. So we'll still be reaching out to, we've already been in touch with, ECMO suppliers regarding that oxygenator specifically. So we're not manufacturing anything. We're taking proven technology and putting it with other proven technology for this purpose.
Is this going to be expensive to the hospitals from your point of view?
I designed it to be extremely cheap. So within what I call my design envelope, I looked at various factors. I looked at availability, supply chain, bottlenecking, ease of use, the amount of knowledge it takes to hook it up and or retrofit the unit. So all these things were on our whiteboard when we designed it, and we made sure that using that existing technology and using these existing oxygenators, we anticipate the retrofit in full to be about $1,000 per unit. Yes. And and then each time you use it after that is cheaper, because you don't have to retrofit it. You're just changing out the oxygenator every time.
I think the hospitals will tell you that's pretty inexpensive. What about training? Is it going to require some specialty training?
So we've talked to medical professionals, across the board. We've talked to phlebotomists, we've talked to RNs, CNAs, we've talked to ECMO perfusionists and specialists. We've talked to ER doctors and all that, and nobody in that arena seems to be intimidated by the idea of using a hemodialysis machine. While it might not be typical for a certain individual to hook up a hemodialysis machine, they have people in their circle that's, okay, this is your job, you're operating the machine. In a pandemic situation, you use what resources you have. We've seen people using some very creative PPE, and we've even seen some creativity when it came to the ventilators. So this is no different when it comes to that. Use what resources you have, and when it comes to cannulation of the patient and monitoring that machine, it's designed to be extremely easy and within their existing knowledge. We'll also be putting together an SOP that will be in a digital format as well as a written format for each of these retrofits as we engage hospitals to start using this.
So now you mentioned, for the pandemic, that this could be rolled out and, utilized very quickly, but are there any long-term applications for this technology after this pandemic?
An interesting data point that a lot of the people that are skeptics about this pandemic have brought up is, well, we lose 300,000 people to the flu and pneumonia every year worldwide. So we actually want to use that data in favor of ECMO here, or echo, pardon me, because those 300,000 people, give or take, that are dying every year, they're dying from a respiratory distress, and this force multiplier of ECMO will become a standard treatment, I believe, for those patients. In a normal flu situation, a bad flu or bad pneumonia, ECMO is not commonly used. It's not commonly used because it's not commonly available, and because it's not commonly available, the standard of the patient, the condition of the patient has to be pretty bad before they even consider it, if it's even available. By having this force multiplier, it'll be readily available to, even some community hospitals and shoot, even possibly some clinics. So having that availability, I believe, will continue to save lives throughout the years.
So to finish up this portion of the video, something you've said to me is that when people are struggling with respiratory diseases or distress or pneumonia, their lungs increasingly, take in less and less oxygen, which is causing stress on the other organs. But with ECHO, the oxygen is readily available for all the other organs, and it seems like it gives the body a break.
Yeah, by default, exactly that. It's taken a load off of all of the vital organs versus increasing that load. And the layman example I like to use is, if you sit on your leg for a small period of time, it's not very long before it starts feeling tingly. That's that's blood not getting flowing to those muscles. That's oxygen not flowing to those muscles. In the same way, when your lungs are in distress, it's not bringing oxygen into your body, into those muscles, including your heart muscles and all that. and it's also not exiting that CO2. So you start to see a combination of two bad things. You see your blood toxicity increase from CO2, and you see a decrease in oxygen. And this inherently causes sudden cardiac arrest, renal failure, liver failure, etc. So it's our belief that by making these readily available in great numbers we've never seen before with ECMO, by introducing echo, we're increasing those numbers so greatly that doctors, administrators, I hate to say it, insurance companies can even look at this and say this is a cost-effective, readily available treatment that is known to work and absolute to work because of that oxygenator right behind your shoulder there. Mm-hmm. So because that technology is so proven, so grounded, it was an obvious to our team to multiply it. And ramping up supply chain, ramping up manufacturing to just manufacture more ECMO units is not realistic when everybody in the manufacturing arena is it's in a frenzy right now. Yeah. So we've got so many manufacturers that are retooling for PPE, retooling for ventilators. Why add more confusion when we already have a pre-manufactured unit called the hemodialysis machine that does everything that we need it to do and at the proper flow rates? It just sometimes the best solutions are the simplest ones.
Jake, I want to thank you for this time and for this explanation, and we're going to do some more of these videos to help explain and break this down. But I want to thank you first of all for being an inventor that actually cares about stopping people from dying and putting together the solution so simply. But I see the work you're doing behind the scenes to get this solution out there. So I appreciate anybody watching this video to help us reach people, to reach the right people, to go to our crowdfunding campaign and help us get this innovation into the hospitals.
And I want to thank everybody for the support. This has been an interesting process, and I'm hoping we can slow the death toll and bring it to a stop and take back control here.
Awesome. Well, thanks a lot, Jake.
Thank you.